Good morning, students. Today we are going to see the last part of Unit 2 climate change modeling. Okay, very interesting topic. Okay, climate change refers to long term alteration in temperature, precipitation, wind pattern, and other climate variables. Water systems are highly sensitive to changes in climate, making them critical indicators of environmental shift. Changes in water availability and quality have far-reaching impact on ecosystem, agriculture, industry, and human health. Okay, I will share my experience, the quality of the water, how far it is important. I was working in NERI as a project assistant during the year 2006 to 2007 at CSA, Council of Scientific Industrial Research. When I went to Pulal area and tried to take out the sample and try to test the water characteristics, and I understand actually how to find out the water quality. Okay, and in a lab as well as how to take out the samples. Similarly, the people who are residing very close to the Pulal area, the northern Chennai, okay, near to the Manali area, their water in the well is a drastic worst condition. Okay, so the people are very interested when we introduce ourselves that we are coming from a National Environmental Engineering Lab to test your water sample which is prevailing here in the underneath the earth, that is their well water. Okay, so they are very keen on because they have given a complaint stating that the water have a smell characteristics. Okay, so there may be a reason and what is the compound which has been mixed into the well water we need to identify. So the changes in water availability and quality have far-reaching impact on ecosystem. Just imagine it affects even the human itself, the human health. Okay, very important point. Okay, so understanding this connection helps in developing the adaptation and mitigation strategies for sustainable water management. Okay, so the sustainable climate, the sustainable environment, this is all we are doing only for the make the next make this planet suitable for living for the humans as well as the other things. Okay, so this is changing, this is affecting because of what? Not by natural means. Obviously, we got hurricane, we got cyclone, we have tsunami, we have what is called earthquake, and all these disasters may happen by natural means. Then nobody will be able to stop it until the God plans, right? So this thing, what I'm trying to say is that this has been alleviated, that means increased for the to a higher level. So that we need to mitigate it. Whatever the action which we are doing, we need to do a remedial action in order to take care of the negative effect of our action. That we need to keep in mind. So the water resources are directly linked to the human survival, economic stability, and ecological health. Climate changes affects rainfall pattern, evaporation rate, snow melt timing, and river flow volumes. Studying these effects helps predict water shortages, flood risk, and drought occurrences. Accurate understanding supports policy development, infrastructure planning, and climate resilient water resource management. Coming to the key drivers of climate change. What are the key drivers? Obviously, greenhouse gases. Okay, land use changes such as deforestation, reduce natural carbon absorption capacity, industrial process. Okay, release additional climate altering pollutant like methane and nitrous oxide. Human induced climate change is amplified by feedback loops such as height melts, reducing relativity and increasing the heat absorption. Coming to the climate models overview, climate models are scientific tools that simulate the Earth climate system under different conditions. So I will just share my experience. Okay, when I was working in Niri, as I told you before, okay, we used to try to find out the air quality in the near to the Trishulum area. Because what happened, they put a case again in the High Court stating that the stone crushing industries are putting a lot of pollutant for the inhabitants who have been living very close to the stone crushing area, that is very close to the opposite to now the Minamagam airport. Okay, Trishul. So just imagine. Okay, so the people will be affected. So during that time, we just try to find a model prediction how the air pollutant has been dispersed. Okay, so to what extent the concentration is high. Okay, that we used to study the particular matter 2.5 and particular matter 10. So these all you might have studied in your environmental engineering course. Okay, so they I don't get into deeper that part. Please try to understand what I mean is that the climatic model has been done purposefully to predict what are the what are the compounds, because of that why it has been increasing. Okay, and in before and we can try to find it out. The climate models are scientific tools that simulate the earth climate system. So the weather pattern as well as the change in climate, how much is it getting increased and so on and so forth. They use mathematical equation to represent physical, chemical and biological process. Okay, models range from simple energy balance calculation to complex coupled atmosphere, ozone, land, ice system. So just see the interacting factors. Okay, so the human made activities will give you a produce a compound or that will change the wind pattern. The wind pattern need to become come into picture, and the atmosphere, ozone, land, ice system is all interconnected. Okay, by adjusting the input, scientists can project future climate scenarios and assess the potential impact. So they can able to predict if you keep on pumping, pumping a lot of greenhouse gases, and nobody want to control the carbon footprint in the next 2 or 3 decades, what will happen? Okay, the planet will not be suitable for the human to live. Okay, and mostly the people nowadays without the air conditioner, the people could not able to survive. Okay, during able to live comfortably during the night time, right? So to sleep comfortably during the night time. So this all happens. Okay, so just imagine, think of all these scenarios. Okay, climate models help predict how changes in temperature and precipitation patterns affect water system. They stimulate the hydrological responses, including stream flow, groundwater recharge, and water quality shift. Models enable scenario testing for different greenhouse gas emission pathways. Such predictions guide decision makers in implementing the climate adaptation measures for water sustainability. Coming to the hydrological modeling basics, hydrological models simulate the movement, distribution, and quality of water in natural and engineered systems. Okay, they integrate the climate data such as rainfall, temperature, and evaporation rate. Models help estimate runoff infiltration. So, what is this hydrological model? The hydrological model will help you to estimate the runoff, that is what is called precipitation, infiltration underneath the earth, and groundwater recharge, that means increase in level in the groundwater under different climate scenarios. So this climate scenarios again depend on the different factors like solar radiation, okay, and then the El Nino effects and the wind pattern, obviously the pressure across between the region. Okay, this all depends on the other factors, and even what you call the aerosols, which affect the wind precipitation. All need to be considered in order to predict the hydrological modeling. This approach is essential for predicting the flood risk, analyzing the word flood risk, droughts, and water availability threats. Okay, climate variables affecting water systems, temperature change influence evaporation, snow melt rate, and water demand. I am not here giving an equation to say how the climate has been predicted by the considering the different factors and writing the equation, but trying to understand what is the advantage of having a modeling pattern so that you could be able to find the weather pattern, hydrological pattern, and wind pattern, and so on and so forth. That will definitely will help you to protect us from the by forecasting. Precipitation variation determine the water availability, flood frequency, and drought severity. Wind patterns affect evaporation rate and moisture transport. Extreme events such as storms and heat waves can cause sudden water system disruptions. Precipitation patterns and climate change. Climate change alters the timing, intensity, and distribution of rainfall. Increased rainfall intensity can lead to flash floods and erosion. Reduced or delayed rainfall can cause water shortage and crop failures. Temperature changes and water resources. Higher the temperature, increase evaporation from soil, water bodies, and vegetation. Warm condition can reduce the snowpack levels, affecting seasonal water availability. Elevated temperatures may increase the water demand for agriculture and cooling system. So elevated temperature may increase the water demand for agriculture as well as the cooling system. So the temperature change is also have increase the water demand. Underline the word water demand. We increase the water demand. Prolonged heat events can also deteriorate the water quality by promoting algal blooms, extreme weather events, and water. Climate changes increase the frequency and severity of floods, droughts, and storms. Floods may contaminate drinking water sources, increasing health risks. So, I don't want to read out the sentences which have been given here. Please try to read it as a self-explanatory. Hope you would understand the modeling, what for we are doing it, and what is the necessity of doing, and trying to find out the prediction. Okay, in order to protect ourselves, and at the same time identify the root cause for that particular changes which has been happening on the planet, our planet Earth. Okay, rivers, lakes, and reservoirs are highly sensitive to climate variability. Reduced precipitation and increased evaporation can lower the water levels. Water flow regions affect navigation, fisheries, and hydropower generation. Sudden surges from extreme rainfall events can cause sedimentation and reduce water quality. Long-term changes require adaptive reservoir operation and watershed management strategies. Impact on groundwater resources. They have given what is the impact on groundwater resources, water quality concerns, and sea level rise and coastal water systems. Sea level rise threatens freshwater supplies in coastal regions through saltwater intrusion. Higher tides and storm surges can contaminate aquifers. Aquifers means nothing but the groundwater. You will have a what you call it a borewell. They will be able to see where the water comes out. Okay, they will have a box like so. It is all the water underneath the earth will comes out. Okay, through the aquifers. Okay, higher tides and storm surges can contaminate aquifers and wetlands. Okay, so aquifers means what a contaminate the aquifers means so that the infiltration will get affected. Higher tides and storm surges can contaminate aquifers and wetlands. Coastal infrastructure, including water treatment plants, faces increasing flooding risk. Loss of coastal wetlands reduces natural flood production. Strategic adaptation measures include managed retreat, sea walls, and freshwater storage systems. Coming to the role of snow and ice in water supply, snowpack and glaciers act as a natural water storage, releasing water during the warmer month. Warming temperature reduces snow accumulation and accelerating melting. Yearly snow melt shift peak river flows, affecting water availability during summer. Yearly snow melt shift okay peak river flows affecting water availability during the summer. Actually, this natural happens melting takes place. Okay, during summer you don't find a water affecting water availability during summer. Okay, it's supposed to be we need water during the summer because of the lot of evaporation. Okay, and the land become dry. Obviously, the level will get down, and the flooding and rainwater will become less during that period. Okay, and also because of the weather condition, the human consumption is considerably quite little high. Okay, so these are the things you need to take. Well, usually during summer, people used to take twice a day. The per capita consumption of water is 135 liters in 2004. Now I don't know, as per the Central Pollution Control Board, go and refer back the amount of water which is required for per capita. Okay, so it is all the water quality. Okay, so just imagine during some 20-25 years back, the scarcity of water is in Chennai is very common. Okay, so after Viranam and rainwater harvesting plant, it has been somehow is manageable right now. Okay, so the glacial retreat threatens long-term water supplies in many mountains, the mountainous regions. Based water management must adapt to declining snow and rise ice reserves. Okay, so hope you understood. Modeling the climate change impacts on water. So, what is the climate change impact on water? Integrated climate hydrology models link atmospheric projection with the water cycle simulation. So, the climate change impact integrated model like climate and hydrology model. Okay, this model assesses how temperature and precipitation changes affect runoff, groundwater, and water quality. Is a self-explanatory. So, they will combine both the climate change as well as the hydrology. Okay, and then try to see the effect of the climate and because of how the hydrology affects. Okay, this will help you to understand the pattern. High resolution models capture local variation while global models provide broader trends. In simple modeling improves prediction reliability by combining multiple models. Model outputs guide infrastructure design, policy making, and resource planning. Okay, so like as per like normal modeling in chemical, you will have you might have studied the modeling patterns. The input is supposed to be given, so there are output is depend on the input and different factors and different combinations. Okay, is linearly linked or non-linear models will be there. Definitely, it's all non-linear. Okay, so just imagine this complexity of the modeling of this particular type of patterns. Okay, that is climate hydrology models. Okay, data requirement. So very important is what is the data requirement? We need a wind pattern. Okay, raise wind direction. Reliable climate data includes temperature, precipitation, humidity, and wind patterns. Okay, so I would like to share my experience in Niri. We used to collect the data from wind direction to go know wind direction and windows diagram. Okay, wind patterns. Okay, we will try to collect the climate. I mean, meteorology data, especially what is the speed of the wind and which direction it flows, how much is the duration the wind flows in that particular direction. When the wind pattern changes, direction changes with respect to time, every 8 hours or every 24 hours, I mean, throughout the day, you will try to monitor this. Okay, so this will help you to understand how the pollutant which has been exhausting out from the chimney or the industrial area dissipated into the thing. Okay, so all this thing you also studied actually, in fact, in your air pollution subject. Okay, just would like to highlight the that type of model, relevant to that particular type of model only we are talking about here, for which again the data requirement is that the wind patterns, humidity, precipitation, rainfall, rainfall, how far the rainfall occurs in the last 2 or 3 decades and things like that, we need to have a input. Hydrological data such as river discharge, groundwater levels, and soil moisture are essential. Remote sensing provides large-scale observation of snow cover, vegetation, and water bodies. Long-term data sets improve trend detection and model accuracy. Data integration from multiple sources enhance the predictive capability. Uncertainty in climate projections. Okay, very important thing. So uncertainty arises from limitation in model resolution, data quality, and future emission. Okay, obviously the certainty, we could not able to predict the thing 100%. Obviously, we could be able to go for the deviation of plus or minus 15%. Okay, either it may be higher or lower. All this plus or minus 15% deviation is acceptable. But more than that, is the model is not valid. Okay, so the people who have taken data analytics and machine learning in the last semester may be aware, very well aware of how to do the modeling. Okay, okay, so just try to understand the complexity of this type of modeling to predict the weather pattern or the climate or climatic conditions and how it affects the other species. Okay, the changes in the input. Okay, natural variability in climate adds complexity to prediction. Different models may provide varying results for climate reason. So sometimes the wind pattern by natural means also it may happen. But most of the time it has been agreement, through the agreement is very clear that because of human activities the global climate change is alarming. Okay, that you need to understand. Downscaling climate models for local applications, climate change impact assessment framework. The assessment process begins with defining objectives and selecting the steady areas. Climate scenarios are generated using GCMs. Okay, are downscale models. Hydrological models simulate water system responses under different scenarios. Results are evaluated for risk to supply, quality, and infrastructure. The framework supports targeted adaptation and policy inventions, adaptation strategies for water system, demand management in changing climate has been given very elaborately. Just go and see actually the points, okay, and try to understand. If you have any doubt, we will again do revision in day to day, face-to-face section today evening. The ecosystem-based adaptation, natural ecosystem regulate water flows and improve quality, restoring wetlands, enhances flood control and groundwater recharge, forest conservation in watershed reduces the erosion and sedimentation in reservoirs, riparian buffers filter pollutants and stabilize the system banks. Ecosystem-based approach provide cost-effective long-term resilience against climate change impact. Okay, coming to the role of policy and governance, very important. Okay, what are the models we have taken and we have found out the root cause for why this is happening, that how to cut down that particular type of emissions or how to cut down the things which is going against the sustainability. Okay, how to mitigate the effect even if we could not 100% nullify the effect. Okay, 100% nullify the cost. Okay, so the strong governance ensure that climate adaptation measures are implemented effectively. That's why this global climate change has been discussed in the United Nations framework or the United Nations framework convention on global climate change. Okay, so this framework, this bodies will try to identify the things root cause for this, and then they will make them to take a severe action or same steps along through the nation. Okay, integrated water resource management promotes coordinated development of land and water policies to incentivize sustainable practices and penalize over extraction. Transboundary water agreements must account for climate-induced flow variability. Stakeholder engagement improves acceptance and success of adaptation measures. Climate change mitigation through water systems, energy-efficient water treatment, and pumping reduce greenhouse gas emission. Wastewater recycling and reuse lower energy demand for freshwater production. So they are trying to say how to recover whatever the action we are doing, because of that the system is getting affected. So we try to mitigate the things. That's what they try. So what they are trying to say, the demand in the fresh water as large quantity has been produced, try to recover that fresh water even for plantation or flushing and things like that, so that we consider the requirement of water we get comes down. Okay, even if the fresh treated water can be used for the steam to run the turbine and things like that. Okay, this all need to be implemented in Singapore. What they are doing, they are treating the what do you call the wastewater and make it into a potable standard, and they are drinking it. It's a very fast approach or a very what do you call it positive approach. Okay, meaning to say the mentality is either fresh water or urine, they treat it to a portable standard, then drink it. So that means what it indicates is that the mentality is going fresh water thing. They are rely on the scientific evidence, not on the our myth or our conception, our perception. Okay, so the hydropower can provide the low carbon energy, but must be managed sustainably. Protecting peatlands and wetlands prevents release of stored carbon. Okay, water utilizers can adapt renewable energy sources of operation. You may ask, what are the effects which are happening by natural means? Obviously, natural means we could not able to control it. But when this is happening by natural means, obviously the system will regain its own position. Okay, the system is in such a way that it will regain its position. But when you made add-on to the particular things, obviously that will not be recovered back easily, and it will not be suitable for us to live in this particular planet, especially. So, what is the case study of California drought and water management? Okay, severe multi-layered droughts highlighted vulnerabilities in water supply system. Agriculture sector faced major reduction in irrigation and allocation. Groundwater depletion accelerated due to increased pumping. Adaptation measures included water rationing, infrastructure upgrades, and desalination plants. Okay, lessons stress the need for proactive planning before crises occur. Case study for Netherlands field management is given role of technology in climate water management. What is future research direction? I get into that directly. Improved coupling of climate and agricultural models for more realistic projections. Development of climate resilient water infrastructure materials. Advance in desalination technologies to energy consumption, to reduce energy consumption. Better integration of socio-economic and environmental factors in models. Exploration of nature-based solution at larger scale for global impact. Exploration of nature-based solution at larger scale for nature-based solutions. So recovered back. Even if you go to the Western countries, inside the houses, inside the what do you call it, building, they will have a plantation because they want to try to reduce the indoor air quality. Just imagine indoor air quality. People have never think about the indoor air quality. Okay, we still say we are developing nation, but only in few places. I don't see even in the government sector they will have a lot of plantation inside the thing. Only for the aesthetic purpose they may keep. They don't really kept for only for not only. I mean, obviously the plantation could be able to absorb. That is a different thing. How many people are really concentrating on the indoor air quality? Just think of. Okay, summary and key takeaways of today's lecture is that, I mean, the last lecture of Unit 2 is that the climate change significantly impact water availability, quality, and infrastructure. Modeling is essential and important for understanding the future risks and planning adaptive measures. Both engineering and ecosystem-based strategies are needed for resilience. Getting back, resilience means coming back to the original position. Okay, policies must integrate science, technology, and community needs. Long-term sustainability requires proactive, flexible, and collaborative water management approach. With this note, okay, I stop it here. I believe you understood the importance of doing a modeling, especially to reduce the effect because of the man-made activities and make the planet to live safe for everyone, including human as well as the other species. With this note, I stop it here. Okay, thank you for listening. We will see in today's evening class at 3:15 in face-to-face section. Thank you.